Welcome back, everybody. This is our video solution to problem 2 from Quiz 6, Spring 2023, Math 302 at Cal State Fullerton. So, we are going, in this problem, to use modular arithmetic to show that 2023 cannot be written as a sum of two squares. So 2023 is a bit of a red herring in this problem, right? The real meat here is in trying to decide which numbers we can't write as a sum of two squares. And if this problem is constructed correctly, 2023 will be such a number. So this is actually something on the homework you were asked to look at. If you had not thought of this before, probably this is a very difficult thing to come up with on the spot. All right, so hopefully you're doing your homework. So the key here is to look at what happens when you square numbers and reduce modulo 4. So let's just make a nice chart of this. So if we're working modulo 4, then I only need to worry about three residues, 0, 1, 2, and 3. All right, and if I square, I'm just going to leave a little extra column here. If I square each of these numbers and I reduce modulo 4, right? So here we're going modulo 4. X squared modulo 4, well, let's see, 0 squared is 0. Mod 4, we can keep it as 0. 1 squared is 1. 2 squared is 4, but 4 is congruent to 0 modulo 4, right? Just subtract 4 from 4, you get 0. 3 squared, well, there's a couple ways I could see this. 3 squared is equal to 9, and then if I subtract 2 copies of 4, I get 1. Alternatively, modulo 4, 3 is the same as negative 1, and so if I square it, I get 1, right? 3 is congruent to negative 1, so 3 squared will be 1 modulo 4. So what you can see is that the squares, all right, the squares are either 0 or 1 modulo 4. Okay, and if I had another number, y, also I could have, right, 0, 1, 2, and 3, then my y squareds are also going to be 0, 1, 0, and 1. So if I'm trying to write 2023 as x squared plus y squared, right, a sum of two squares, then if I reduce that modulo 4, I need to be taking either a 0 plus a 0, or a 0 plus a 1, or a 1 plus a 0, or a 1 plus a 1. Those are the only options for x squared and y squared, right? They're either 0 or 1. There's 4 options. So we know that modulo 4, x squared plus y squared, is congruent to, well, let's see. If I take 0 and 0, I'll get 0. If I take 0 and 1, I get 1. If I take 1 and 0, I get 1. And if I take 1 and 1, I get 2. Okay, so modulo 4, there are exactly 3 options for x squared plus y squared out of 4 options total, right? There's one missing option, right? Namely, we cannot get 3 modulo 4. Now, we saw in the last video that 2023 is congruent. Well, let's see, there it was modulo 8, it was congruent to 7, but we had a way of reducing it modulo 8, right? We were able to subtract 2,000 right off the bat. So let's do that. This was congruent modulo 8 to 23, but also modulo 4 to 23, because 4 also has to go into 2,000. And now, if I reduce again modulo 4, I say, well, okay, let me get rid of 5 4s, right? Get rid of 20. I get down to 3. So 2023 is congruent to 3 mod 4, and that is the one number, right, the one residue that x squared plus y squared cannot be. So since x squared plus y squared is not congruent to 3 mod 4, and 2023 is congruent to 3 mod 4, there do not exist integers x and y such that 2023 equals x squared plus y squared.